Welcome to the week 9 maths graded assignment solution video. So the first question states there is a function given and it's defined in the interval -1 to 1. So based on this data we have to calculate its area with the x-axis and its graph. So the first function is f of x is given by x. So the graph for this particular function will pass through origin having slope is equal to 1. Since it is defined from -1 to 1 and it is an odd function, so its area will be 0. So for the function f of x, its area will be 0 and its graph will be the third one. Now the second function is mod x. So for mod x, the graph is like this one, okay, and it is defined from -1 to 1. So it is symmetric about y-axis. So we will compute. So let us compute area of this triangle. So it is 1 unit as well as this one is 1 unit. So area will be equal to 2 times half 1 times 1. So it will give 1. So for the particular function mod x, its area will be equal to 1 unit and its graph will be this one, okay. So for the mod x, its area is 1 and its graph is the first one. So the remaining is the f of x is equal to x square. So its graph is like this one. It is symmetric about y-axis and we can compute its area on the either side of y-axis and then multiply it by 2, okay. It is symmetric about y-axis. So its area will be 0 to 1 x square dx. So it will be 𝗪𝗚3 times 2 from 0 to 1. So it will be equal to 2 by 3. So for the function f of x is equal to x square, its area will be equal to 2 by 3 square unit and its graph is this one. So its area is 2 by 3 unit and its graph is the second graph. Now the second question states there is a cylinder which is inscribed in the sphere of radius r and the cylinder has height is equal to 2h. So based on these statements we have to compute the condition when the cylinder has maximum volume and the cylinder when it has maximum surface area, then what will be the relation between the height of the cylinder and the radius of the sphere. Since volume of the cylinder is given by 2 pi x square h and this is a right angle triangle, so from here we can write h square plus x square is equal to r square. So x square will be equal to r square minus h square. So we can substitute x square is equal to r square minus h square in this volume. So volume will become 2 pi r square minus h square times h. So now volume will become 2 pi r square h minus 2 pi h cube. So for V max we will compute dv divided by dh, that means volume, derivative of volume with respect to height, which will give 2 pi r square minus 2 pi times 3h square, okay, and then we will equate it to 0. So 2 pi will vanish, so r square minus 3h square will be equal to 0. So when the cylinder have its maximum volume, when the cylinder has maximum volume, then h square will be equal to r square divided by 3. That means h will be equal to r divided by root 3. So the third statement is correct. For maximum volume, the height should be equal to r divided by root 3. Now we have to find the condition for its surface area. So now we will move to find what will be the relation between h and r when the cylinder have maximum surface area. So surface area is given by 4 pi xh, and we know xy is equal to r square minus h square half times h. So it will be equal to 4 pi r square h square minus h to the 4 under root. Now we will find derivative with respect to h. So it will be equal to 4 pi half r square h square minus h to the 4 half minus 1 by 2 times r square times 2h minus 4h cube. Okay, so this will go in the denominator part, so this term will vanish. So r square times 2h minus 4h cube will be equal to 0. So that imply r square h will be equal to 2h cube. So one h will balance the other h, so it will be equal to h square. So h will be equal to r divided by root 2. So by solving for the maximum surface area, we will get we got h should be equal to r by root 2. So this statement is correct. So the third question states there are 4 graphs given below, and we have to choose those graphs which has negative area on the x-axis between the interval 0 to 1.